31st question. A circular coil of 100 turns has a diameter of 4 centimeter. The current that must flow through the wire in order to produce a magnetic field of 300 microtesla at its center. So there is a coil. So in that coil, the current is flowing and it produces the magnetic field. And what is the magnetic field at the center? Magnetic field at the center is 300 microtesla. So we have the formula for the magnetic field at the center. B is equal to mu naught Ni divided by 2R. So this, what we are asked to find, we are asked to find the current required to produce a magnetic field of 300 microtesla. So I is equal to B into 2R divided by mu naught into N. So I can write this is B is nothing but 300 microtesla into 2R is nothing but the diameter. So I can write it as 4 into 10 to the power minus 2 divided by mu naught is 4 pi into 10 to the power minus 7 into N is nothing but 100. So we'll write it as 10 to the power 2. So it reduces to, so 4 gets cancelled. So remains with this 3, I'll write, divide by pi. Then this power 300, 10 to the power 2, I can cancel with this 3, 10 to the power minus 2. So 10 to the power, this is the minus 7 and 2, it becomes minus 5. Minus 5 comes to the numerator, it becomes plus 5. So it becomes 10 to the power minus 1. So altogether it becomes 0.3 by 5 amperes. So current is 0.3 by 5 amperes. Next question. The figure shows the time displacement curve of a particles P and Q. So this is the xt graph. So we have the xt graph for the P and Q. So P ಮತ್ತು Q ಗೆ ಇರುವಂತ xt graph ಕಾಣ್ತಾ ಉಂಟು. Okay. ಈಗ ನಮಗೆ ಏನು ಕಾಣ್ತಾ ಉಂಟು ಇಲ್ಲಿ? So we can see that the graph P has a slope greater than the graph. So I can say the slope corresponding to the particle P is greater than the slope which is corresponding to the particle Q. And moreover, the slope is a constant. So for both the graphs, it is nothing but the slope is a constant. What does it mean? The slope is constant. Slope, what the slope of xt graph gives? Slope of xt graph gives us what? Gives us the velocity. So the first thing what we can decide is the P and Q are moving with, so P and Q both are moving with a uniform velocity. First thing, it moves with a uniform velocity. Why? Why? Because the slope is a constant. Second thing, slope of P is greater than slope of Q. That is why I can say velocity of P is greater than velocity of Q. So these two are the conditions. Either both P and Q move with the uniform equal velocity. No, this is not the answer. So it's not equal. P is accelerated and Q is retarded. No, since it's a straight line graph. So straight line graph represent the uniform velocity. So it cannot be the B1. See, both P and Q move with uniform velocity. Right, one point is correct. But the velocity of P is more than that of the velocity of Q. Right. Yes, this must be the answer C. So both P and Q move with uniform velocity, but velocity of Q is more. No, Q has a slope lesser. So velocity of Q is lesser than the velocity of P. So the option must be the C1. Right. The magnetic flux in Weber in a closed circuit of resistance 10 ohm varies with the time as phi is equal to 6t square minus 5t plus 1. The magnitude of the induced current at t is equal to 0.25 second is. So what we have formula? We have the formula for the induced current I is equal to 1 by R into the magnitude of induced EMF. So what is induced EMF? Magnitude of the induced EMF is equal to magnitude of d phi by dt when t is equal to 0.25 seconds. So if you differentiate this phi, what you'll get? You'll get it as the magnitude. So 12t minus phi at t is equal to 0.25 seconds. So you substitute this 12 into 0.25 for the easier calculation. I will substitute as 1 by 4 minus 5. So it becomes the magnitude of minus 2. So 4 3s are 12, 3 minus 5 is minus 2. So magnitude will come to the 2. So it will be the 2 volt. Now what is the current I? So I will be equal to 1 by R is how much? 10 ohm into the magnitude is 2 volt. So it will be 0.2 ampere. So the option will be the A1. Next question. If the number of turns per unit length of a coil of a solenoid is doubled, the self-inductance of the solenoid is direct. Easy question. So we know that the self-inductance of a coil is directly proportional to the number of turns per unit length. We have the relation L is directly proportional to N square. So that implies the L2 by L1 is equal to N2 by N1 whole square. So what is given? Number of turns per unit length is doubled. So N2 is equal to 2 times N1. So this will be equal to 4. So it's 2 square. So that implies L2 will be equal to 4 times that of L1. So when it is doubled, since it is a square relation, it becomes a 4 times. So option is D. Okay. In an alternating voltage, E is equal to 200 root 2 sine 100t volt is connected to a 1 microfarad capacitor through an AC ammeter. So there is an AC ammeter connected. The reading of an AC ammeter is. So what is given? The EMF source is nothing but E is equal to 200 root 2 sine 100t. Right? Now, what is the general expression? General instantaneous EMF is equal to E maximum into sine of omega t. So if you compare these two, now what you will get is nothing but E maximum is equal to 200 root 2 and also the omega is equal to 100. Okay, right. Now what the ammeter reads, and AC meters, what they read the RMS value of the current or the RMS value of the voltage. Here the ammeter is connected, so the reading, it will be the RMS. So what we are asked to find? We are asked to find the IRMS. So we are asked to find the IRMS, right? Now to find the IRMS, we should get what is first ERMS. So how to find ERMS? If E maximum is this much, so that implies what is ERMS? ERMS will be equal to 1 by root 2 times that of the E maximum. So that is equal to 1 by root 2 times 200 to root 2. So root 2 cancels. You will get is nothing but the 200 volt. Okay. Now what is IRMS? Now IRMS is equal to ERMS divided by, it is a capacitive circuit. So capacitive circuit, capacitive reactance is XC, or else that is equal to ERMS divided by 1 by omega c. See, so omega c comes up. So it is nothing but ERMS into omega c. So that is equal to 200 into omega is 100 into c is how much? C is given to be 10 to the power minus 6. So it comes to be, so this 2 power, this is 2, so 10 to the power 4, so 10 to the power minus 6. So it becomes 2 into 10 to the power minus 2. Is it there? No. So this we can write in another way as 20 into 10 to the power minus 3. Or else that becomes equal to 20 milliampere. So IRMS. So the answer will be 20 milliampere. So 20 milliampere is option is B. Right. 36th question. The time taken by an AC of 50 hertz in reaching from 0 to its maximum value is. So if I draw an AC, so AC signal like this. So if I take this further, this as a fraction of time, then say this, if I take it as a say EMF or the voltage or anything. Now this is from 0 and this is the maximum value. So what we are asked to find, what is the fraction of time wherein the EMF or the voltage or the current, whichever the parameter asked AC, it reaches from 0 to a maximum. So now we know that to complete one cycle, what the time takes, it is nothing but the period. So from here to here, it is nothing but the period. So once if it has to reach from 0 to maximum, means the time will be equal to T by 4, 1/4 of the time. Okay, now T is given. No, the frequency of AC is given to us. So frequency is given to be 50 hertz. So we have period is equal to 1 over frequency, that is 1 by 50. So it is nothing but 0.02. So second. So what is the time then? The time at which the AC signal goes from 0 to maximum is T by 4. So T by 4. So we can write it as 0.02 divided by 4. So this will be equal to, for a how to simplify easily, you can write is 2 into 10 to the power minus 2 divided by 4. So we simplify, 2 ones are 2 twos are, so 1 by 2. So 1 by 2 into 10 to the power minus 2. 1 by 2 is nothing but 0.5. 0.5 into 10 to the power minus 2. So is it the answer? So we can write it as 0.005. So the option will be the B one, right? Next, a body having moment of inertia about its axis of rotation equal to 3 kg meter square. So moment of inertia was 3 kg meter square, right? Is rotating with an angular velocity of 3 radian per second. So omega is how much? Omega is nothing but 3 radian per second, right? Now, so kinetic energy of the rotating body is same as that of a body of mass 20 kg, 27 kg moving in a straight line with a velocity equal to, that means, say imagine something is rotating, say a disc or ring or whatever, I don't know. Say it is moving, say it is rotating along this, it has some what the moment of inertia and the angular frequency. So it possesses some kinetic energy, rotational kinetic energy. Now, the rotational kinetic energy of this, if it has to become equal to the kinetic energy of a body of mass, say 27 kg, say a body of mass, say A, it moves with some velocity v. What is the question asked? The kinetic energy of this body moving along a straight line is equal to the kinetic energy of this rotating body. Then what should be the velocity of the moving particle? So we have the formula for kinetic energy of, for the, say, kinetic energy of rotational motion. Say Kr, we have half into I into omega square. Whereas a translational kinetic energy is nothing but half into mv square. So this is given the question that Kr, rotational kinetic energy, is equal to translational kinetic energy. So half into I omega square is equal to half into m into v square. So half of this cancel. We are asked to find the v. So let us take the v square. V square is equal to I omega square divided by m. So I is 3. Then for the omega is 3. So 3 square divided mass is 27. So that is equal to 1. So therefore, what you can write, V is equal to 1 meter per second. So V square comes to be 1 and V comes to be equal to 1. So the answer will be the A1. Right. 38. A lens of power 6D is put in contact with a lens of power minus D. ಏನಂತೆ ಎರಡು ಲೆನ್ಸ್ ಇದೆ, ಒಂದು ಪವರ್ 6D ಇಷ್ಟಿದೆ, ಇನ್ನೊಂದು ಪವರ್ ಎಷ್ಟಿದೆ, ಇನ್ನೊಂದರ ಪವರ್ -4D ಇದೆ. They are kept in contact. Then the combination will behave like. Combination ಹೇಗೆ behave ಆಗುತ್ತೆ ಅಂತ ನೋಡಬೇಕಿದ್ರೆ ಏನು ಮಾಡಬೇಕು ನಾವು, ಪವರ್ ಟೋಟಲ್ ಪವರ್ ತೆಗೆದು. So power of the combination, total power is equal to P1 plus P2. So that is equal to 6 minus 4. So that is equal to 2D. So power in bantiga, power comes to be positive. First thing. A combination, what does a power positive means? Say either power 6D, then this is a convex lens with a power 6. Then here the minus sign indicates that it is a concave. So whenever we get a power as a positive, it implies that it must be a convex lens, or what we call the convergent in nature. So the combination will behave as a convergent first. Now, what is the focal length? So we have the relation focal length of the combination F is equal to 1 by total power. So it is 1 by 2. So 1 by 2 is nothing but 0.5. What 0.5? If power is in diopter, the focal length what comes, it is always in meter. So it is 0.5 meter, or else you can write it as it is nothing but say 50 centimeter. So focal length of 50 centimeter and a convergent. So which is the option? So option comes to be convergent length of focal length 50. So the option is B. Okay, then the 39th. In a series LCR circuit, if the frequency of AC is half that of the resonant frequency, then we have to see what is the relation between the voltage and current. Okay, put a condition, angular frequency is it is nothing but half of the resonant frequency. Okay, what we know that when omega is equal to omega naught, then what happens? Xc becomes equal to XL and the Z becomes equal to R. So that implies the phase difference is 0. At resonance, XL becomes equal to Xc and Z becomes equal to R. Pure resistive circuit, it behaves like. So the phi becomes equal to 0. That means what? V voltage and current are in phase. Yavaga andre resonant frequency. Ivaga omega is equal to omega naught by 2 means what is the frequency? Frequency is less than omega naught. So what happens when omega is less than omega naught? This Xc will be greater than the XL. So wherein that implies when XA is greater than XL, this combination behaves like an capacitive circuit. So it behaves like a capacitive circuit. So we know that if it is a pure capacitive circuit, current leads the voltage by pi by 2 when it is a pure capacitive circuit. Here it is not a pure capacitive circuit. Why? Because it has an L, it has a C, and it has a R. So since it is not a pure capacitive circuit wherein there is a L, C, and R combination, so the angle will not be equal to pi by 2, but when omega is less than omega naught, since XC is greater than XL, the capacitive circuit or the capacitive property will be dominant one. That is why the current will lead the voltage by an angle other than the pi by 2 or less than the pi by 2. So the option must be current leads the voltage by certain angle. So if say some other question, if it is asked omega frequency greater than omega naught, if it is a greater than omega naught, then what happens? XL will be greater than XC, wherein it behaves like an inductive circuit, and then what happens? The voltage leads the current. So A must be the option there. But in the given question, the option is B. So current leads the voltage, right? 40th question. A monochromatic light from a narrow slit illuminates two narrow parallel slits, producing an interference pattern on a screen. So there is a single slit illuminates another double slit, and it produces a interference pattern on the screen. Okay. The separation between the two slits is now doubled. That means separation between the slits D2 is equal to 2D1. Okay, right. Distance between the screen and the slit is half. So D2 is equal to D1 divided by 2. Now the fringe width becomes, so what is the formula for fringe width? Fringe width is equal to D lambda divided by D. So what we can write, beta 2 by beta 1 is equal to D2 divided by D1 into D1 divided by dt. So that is equal to, what is D2? D2 is half of the D1, so it becomes 1 by 2. What is D2? D2 is 2 times that, so it becomes 1 by 2. So it will be 1 by 4. So the new fringe width will be equal to 1/4 of the initial fringe width. So the option must be 1 by 4. Yes, the plane wave of wavelength 600 nanometer. So lambda is equal to 600 nanometer. Falls normally on a slit of width point. Say slit width A, I'll take it as a 0.2 millimeters. Angular width of the central maxima. So what is the angular width? Angular width of central maxima of a diffraction is equal to 2 lambda by A. So direct formula, 2 into lambda is 600 nanometer. So 10 to the power minus 9 divided by A. A is nothing but 0.2 into 10 to the power minus 3. So that is equal to, so this you can write it as 2 into 10 to the power minus 4. So 2 gets cancelled. So it will, so this will be minus 4. Minus 4 goes up. It becomes plus 4. Plus 4 is nothing but this here remains with the, say there are power 2 here. So it becomes plus 4 and plus 6. So it becomes minus 3. So it will be altogether 6 into 10 to the power minus 3. So that is equal to 0.006 radian. So the option must be this C. Right. Light of wavelength 4000 angstrom is incident on a metal whose work function is 2 electron volt. The maximum kinetic energy of the emitted photoelectron is. So, what is the case here? So, wavelength is incident wavelength is 4000 angstrom. Then the work function is nothing but 2 electron volt. Then the maximum kinetic energy emitted. What is the formula for K maximum? K maximum is equal to the hc by lambda, that is energy of photon minus the work function phi. Okay. ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ, ನಮಗೆ ಕೊಟ್ಟ ಕೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಪ್ಷನ್ಗಳೆಲ್ಲ ಯಾವುದರಲ್ಲಿದೆ? ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಲ್ಲಿದೆ. Phi ನಮಗೆ ಕೊಟ್ಟ ವ್ಯಾಲ್ಯೂ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್, so it is in electron volt. So if you are to subtract this, then this hc by lambda also we have to represent in electron volt itself. So this is in joule. So what we have to do? We have to divide it by the charge of an electron. Then this also gets converted into an electron volt. Okay. ಇಲ್ಲೊಂದು ಟರ್ಮ್ ನೋಡ್ಕೊಳ್ಳಿ, ಈ hc by e ಇದೆಯಲ್ಲ, ಇಲ್ಲಿ ಈ hc by e ಇದೆಲ್ಲವೂ ಕಾನ್ಸ್ಟೆಂಟ್, ಎಚ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಸಿ ಕಾನ್ಸ್ಟೆಂಟ್, ಇ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ನಮಗೆ ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ನ ವ್ಯಾಲ್ಯೂ ಡೈರೆಕ್ಟ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಬಹಳ ಅಡ್ವಾಂಟೇಜ್ ಆಗುತ್ತೆ. ನೋಡಿ, ಎಚ್ ಸಿ ಇದರ ಪ್ರಾಡಕ್ಟ್ ಎಷ್ಟು ಬರ್ತದೆ ನೋಡಿ. ಎಚ್ ನ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು? 6.625 into 10 to the power minus 34 and c value is 3 into 10 to the power 8. See, when you multiply this, it roughly comes to 20 into 10 to the power minus 26. Which one? hc. So ಇದು ನಮಗೆ ತುಂಬಾ ಕಡೆ ಯೂಸ್ ಆಗುತ್ತೆ. ಅದನ್ನು ಹಾಕಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ಕೂತ್ಕೊಳ್ಳೋದಕ್ಕಿಂತ hc is roughly equal to 20 into 10 to the power minus 20. ಓಕೆ, ಮುಂದುವರೆದು hc by e ಇದ್ರೆ ಕೆಲವು ಕಡೆ ನಮಗೆ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಕನ್ವರ್ಷನ್ ಇದು ಬೇಕಾಗತ್ತೆ. ಸೊ ಇದೆಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, 20 into 10 to the power minus 26 divided by 1.6 into 10 to the power minus 19 charge of an electron. So ivaga if you divide 20 by 1.6, it almost comes to be 12.4 into 10 to the power minus 19 goes up, it becomes 10 to the power plus 19. So plus 19 means it remains with 10 to the power minus 7. So this equal to ಇದನ್ನ ಯಾವತ್ತು 10 to the power minus 10 ಅಲ್ಲಿ ಬರ್ಕೊಂಡ್ರೆ ನಮ್ಗೆ ಇಲ್ಲಿ ಯಾವುದಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ಗೆ ಚೆನ್ನಾಗುತ್ತೆ. ಸೊ ದಿಸ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಆಸ್ 12,400 into 10 to the power minus 10. ಸೊ ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಬಹುದು. ಸೊ hc by e, better you remember it as either 12.4 into 10 to the power minus 7. ಈ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಕಷ್ಟ ಆಗುತ್ತೆ, ಅಂದ್ರೆ 12,400 into 10 to the power minus 10. ನೋಡಿ ಇಲ್ಲಿ ಎಷ್ಟು ಈಸಿ ಆಗುತ್ತೆ ಈಗ ಅಂತೇಳಿ. So this hc by e I can substitute as 12,400 into 10 to the power minus 10 divided by what is lambda? Lambda is nothing but 4,000 angstrom. 4,000 angstrom 10 to the power minus 10 minus 2 electron volts. So that is equal to, this is get cancelled. So 20 get cancelled. 40, 124 divided by 40. 43 is a 120. So this comes to be 3.1 minus 2. So the answer will be 1.1 electron volt. So the option is B. So better you remember this one is this one and another one is this hc by e. So the option is 1.1 electron volt. Okay. 43rd, what will be the ratio of de Broglie wavelength of proton and alpha particle moving with the same energy? So what is the expression for the lambda in terms of energy? Lambda is equal to h by square root of 2me. So h is anyhow constant. It's given that both our proton and alpha particle have the same energy. So what you can write? Lambda is inversely proportional to square root of their mass. So we can write the ratio of lambda corresponding to the proton. So lambda corresponding to the proton to, say, proton to wavelength of alpha particle is equal to the square root of mass of alpha particle divided by mass of the proton. So that is equal to, we know that if the mass of proton is 1 unit, the mass of the alpha particle will be the 4 units. So that will be equal to 2 by 1. So the answer will be equal to 2:1. Right. 44th. The ratio of minimum to maximum wavelength in Balmer series is. So what we have the formula for the wavelength of a spectral series of Balmer. So straight away we'll write for the Balmer series. So we have 1 by n1 is 2. So we'll write the 2 square minus 1 by n square. Correct? Balmer series direct. Ivaga. If we want to get the lambda minimum, when we will get lambda minimum sigbeku antadre, the photon should possess the maximum energy. When the maximum energy possible, when the maximum value of n is. So what should be the, for lambda minimum, n is equal to how much? N is equal to infinity. So therefore I can write it as 1 by lambda minimum is equal to r into 1 by 2 square minus 1 by infinity square. You need not substitute all this because 1 by infinity square, you know that it is a 0. So it comes to be equal to r by 4. All right. Then what is lambda minimum straight away? So if you are taking lambda minimum is equal to 4 by r. Now, coming to the lambda maximum. When the lambda maximum comes out, the wavelength will be the longest one when the photon has the smallest energy. If the smallest energy has to get emitted, the electron has to jump from the immediate higher orbit. Immediate higher orbit is n is equal to 3. So therefore, 1 by lambda maximum is equal to r into 1 by n square, that is 1 by 2 square minus 1 by 3 square. So it is r into 1 by 4 minus 1 by 9. So it becomes 5r divided by 36. Or else lambda maximum is equal to 36 divided by 5. Now you take the ratio of these two. What is the ratio of lambda minimum to? So lambda minimum to lambda maximum is equal to, so this here, lambda minimum to lambda maximum, that is 4 divided by r divided by 36 divided by 5r. So r gets cancelled. 4 ones are 4 nines are, so 5 goes up, so it becomes 5 by 9. So option will be the A. Next one. A heavy nucleus at rest breaks into 2 fragments which fly off with the velocities 8:1. The ratio of radii of the fragments. So if you think of, say, the one, say, heavier nuclei, it is given that it is at rest. So what should be the initial momentum? The initial momentum should go to 0. Now, when it explodes, say, if this is the one part, smaller part, say if it goes in this direction, say the another block has to go in the opposite direction. Why? Because the before say initial momentum, if it is 0, then the total momentum after also should go to 0. In other words, if this part, say if a part A gets momentum in this direction, B part should get a momentum in the opposite direction, so that the magnitude of momentum of the one fragment should be equal to the magnitude of momentum of the second. So I can write it as, if say I can write mass of the one fragment say as m1 and the velocity of the one fragment as a m v1. So this gives the momentum of the first fragment, that is equal to momentum of the second fragment, that is nothing but mass of the second fragment into the velocity of the second fragment. Okay. Now, what is m1 by m2 now? m1 by m2 will be equal to v2 by v1. What is that? It is given that the fragments fly off with a velocity of 8:1. So the velocity of v1 is to v2 is equal to 8:1. So it is given that v1 is to v2 is equal to 8:1. So I can write this as v2 by v1 is nothing but 1 by 8. Okay. 1. Now, what we are asked to find? We are asked to find the radius. How to come to the radius one? Now, for whether it is a heavier nuclei or else whether it is a lighter nuclei, what property remains same in both the case? That is nothing but the density. Nuclear density is a constant. So what? The density of the first fragment should be equal to density of the second fragment, irrespective of the size, irrespective of the momentum. Density has to remain constant. What is the density formula? Density formula is nothing but mass per unit volume. So I can write m1, this capital V I am writing as a volume 1. So that must be equal to density, the mass of the second fragment. So the mass of the second fragment divided by the volume of the second fragment. Okay. Now, what is the volume of what we know? The nucleus is spherical in shape. So volume I can write it as a pi r 4 by 3 pi r cube. So 4 by 3 here cancels, pi gets cancelled, only r cube term. So I can write this m1 divided by r1 cube is equal to m2 divided by r2. Right. So we'll rearrange this. So that implies what we want. Ratios of the radii. So let us take the ratios of radii. R1 by R2 whole cube. Say R1 by R2 whole cube is equal to M1 by M2. Now, so that implies R1 by R2 is equal to cube root of M1 by M2. That is, what is M1 by M2? It is 1 by 8. 1 by 8 cube root comes to be equal to 1 by 2. So it will be 1:2. See? So the first part, if it flies with a velocity 8 times that of the second one, the size of such that the second one will be twice the size of the first one. So higher the volume, its speed will be lesser. Lesser the volume, the speed will be higher. So here the ratio comes to be 1 by 2. So the 1 by 2, the velocity will be equal to 8:1 and the radii will be equal to 1:2. Okay, right. 46 one. In an experiment on a scattering of alpha particle by a gold nuclei, the closest distance of approach is observed to be, say, if I take closest approach as R0, so 30 fermi. Okay. If the velocity of alpha particle is doubled, so what is done? Velocity second time it is 2 times that velocity. V1. Okay. Now the closest distance of approach will be. So what is closest approach? Say if I say this is an alpha particle moving with certain kinetic energy. Kinetic energy is what? Half mv square. Towards what? Towards it is projected towards a gold nucleus. So say if I take the ZE, this is the nucleus. As it comes closer and closer, what happens? Kinetic energy gradually decreases, right? So kinetic energy gradually decreases. So till what distance? Say if imagine if it can reach alpha particle till this. So this distance, what we refer it as the closest distance of approach, or it is nothing but the closest distance of approach, say R. Now what happens as it comes closer and closer? Its kinetic energy gradually decreases and decreases. At one position, the kinetic energy becomes completely zero. So what happens then? Then the system of alpha particle and the nucleus, it will have its own potential energy. So total kinetic energy of this alpha particle becomes equal here to the potential energy. So gradually kinetic energy decreases and the system of this particle gains the potential energy. So what is happening there? The kinetic energy of the particle, that is half mv square, becomes equal to the potential energy, that is 1 by 4 pi epsilon naught. Say this is an alpha particle. So if I take the alpha particle charge as Q into, so I can write it as a 2E also, no problem. Then the Z into E, that is the nucleus, divided by, if I take this R naught, say this will be the R naught. So what is here, all these terms, it's not important for us. See, we only look into this one. So what? Then we'll see that the closest distance of approach is inversely proportional to the V square. Right? So inverse relation here. That means what? Higher the speed of the coming alpha particle, closer it goes to the nucleus. So this is R naught is directly proportional to 1 by V square. Once we know this relation, it's a very easier one. So I can write, say R naught 2 divided by R naught 1 is equal to V1 by V2 whole square. So that is equal to, what is V2? V2 is 2 times the V1, so it becomes 1/4. So I can write, what I can write is R naught in the second time is equal to 1 by 4th of R naught 1. So when you double the velocity, it goes so close that the closest distance of approach reduces to 1/4 of its initial value. So reduces to 1/4 of its initial value. All right. Which of the following electromagnetic wave has the longest wavelength? So you know that the wavelength, say the photon which has the highest energy is X-ray. Next it comes the infrared, next it comes the microwave, and next it comes the radio waves energy wise. So when the energy is least, wavelength will be the longest one. So which is having the longest wavelength? It is out of this option, it will be the radio waves. In a semiconductors at room temperature. So we know that in a semiconductor at, say, at 0 Kelvin, semiconductor behaves like what? Semiconductor behaves like an insulator. So only in insulator, what is that? The valence band is completely filled and the conduction band is empty. So what happens when it is brought to a room temperature? At the room temperature, what happens? Due to the absorption of heat energy, a few bonds will break, and the breaking of the bond will result in few free electrons. So at room temperature, valence band is not completely filled. That is, few electrons jump into the conduction band. So valence band and the conduction band must be partial empty. So The valence band is partially empty. Okay, it's possible. And the conduction band is partially filled. Yes, this is also possible. Let us see this one. The valence band is completely filled. No, valence band cannot be completely filled in case of a semiconductor at room temperature. Here also the same, valence band is completely filled and conduction band is empty. No, this is not possible. The conduction band is empty. No, a semiconductor shows slight conductivity at room temperatures. That is why this option is not proper. So the option has to be the A1 itself. The valence band is partially empty and the conduction band is partially filled. Yes. A force F acting on an object varies with a distance x as shown here. The force is in N, Newton, and x in meter. The work done by the force in moving the object from x is equal to 0 to x is equal to 6 meter is. So straight away, what is the work done? Work done, we can get it from the Fs graph as the area under Fs graph. Okay, so what is the area here? Now you can see that this area. So there is this area of this rhombus. So this structure. So straight away you can go with the formula if you want half into height into sum of the parallel sides. One step. So here you'll get half into height is nothing but 3 units, that is 3 into A parallel sides are this, one is this. So if you drop this, you'll see that this is 3. So A is 3, then B becomes 6. So it becomes 6 plus 3, 9, 9 3 is 27, 27 by 2 will be equal to 13.50. If you don't remember this formula, then you can divide this area into 2. That is, the area of one square comes, then area of this rectangle or the triangle comes. Then you can add the area of a rectangle or the area of the square plus area of the triangle. You'll get the same answer of 13.5. Yes. If the conductivity of a material is only due to bond breaking, of the breaking of the covalent bond, then due to the thermal excitation, then the material is. So can it be conductance? No. Kind of conductors, conductivity is not because of the breakage of the bond. In an intrinsic semiconductor, yes, this is possible one. Extrinsic semiconductor, in an extrinsic semiconductor, it is not only due to. In an extrinsic semiconductor, conductivity is due to the impurities and as well as because of the bond breaking. And insulators, in an insulator, bond breaking don't take place. So the option has to be B1. So in an, let us very clear, in an intrinsic, it is a pure semiconductor wherein there is no impurity. That is why the conductivity has to come because of the bond breaking. So the option has to be the B1. Yes. The resistance of a galvanometer is 50 ohm. So Rg, resistance of the galvanometer is 50 ohm. It is given that for a and requires 2 microamperes per 2 division of deflection. So what is I by theta is equal to 2 microamperes for how many deflection? 2 deflections or 2 divisions. Now the value of shunt resistance required in order to convert a galvanometer into an ammeter of range 5 milliampere. Sorry, the range of 5 ampere. Then the number of division on one side of the galvanometer is given to be 30. So once I by theta is given, let us find out what is the current required for full scale deflection. That is, for 2 in deflection, if it needs 2 microamperes, then what is the current required for 30 deflection? So I by theta into N. So, and write 2 into 10 to the power minus 6 divided by 2 into 30. So, you will get it as 30 micro ampere, the first one. Right. Next is direct formula for the shunt resistance S. S is equal to IgG into Rg divided by I minus Ig. That is 30 into 10 to the power minus 6 into what is Rg? Rg is 50 divided by I is how much? 5 ampere minus, say this, you can write in a simpler way. So you can write it as 0.3 into 10 to the power minus 4. Correct? No? 0.3 into 10 to the power minus 4. Or else you can write it as 0.00003. Yes, ampere. So let us keep it a why, because to subtract we should not write in a power. So let us write it like this. Now this I can write it as, so this 0 and this 0 I'll take it as a 10 to the power 2. So 3 5s are 15. So I'll write here the 15 into 10 to the power minus 4 divided by, now you see 5 minus 0.0003. So this subtraction is not going to change the value much. So I can approximately take it as a 5 itself. So for a simple easier calculation, so I will take it as a 5 itself. So 5, so 5 3s are 15, 3 into 10 to the power minus 4. So this will be the answer, 3 into 10 to the power minus 4 ohms. So the C. Right. Now, a wire has a non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which one of the following statement is correct? So first point what you have to note down is I is steady. So I is steady means the current I remains a constant throughout the wire, irrespective of the area of cross section. Okay. All the options are regarding the drift velocity. So let us see what the drift velocity formula we have. I is equal to NEA into VD, or else drift velocity VD is equal to I divided by NE into A. So it's given that I is steady, so current is not changing. So N is anyhow constant, E is anyhow constant. So drift velocity is inversely proportional to area of cross section. So higher the area of cross section, lesser the drift velocity. Lesser the area of cross section, higher the drift velocity. So what should happen if I take the drift velocity at A as VDA, drift velocity at the end of this, say VDB? Obviously, what happened? The electrons, when they drift from A to B, the drift velocity gradually decreases. Why gradually decreases? As the area of cross section goes on increasing, drift velocity has to decrease. So the drift speed decreases on moving from A to B. So the option must be the C one. Right. The force between 2 point charges separated by a distance d in air, medium, and in the given dielectric medium of dielectric constant K are same. What's that? Say if I take one charge of say Q1 and another charge of say Q2, and I will keep this in a distance d, in which medium? I am keeping this in air medium. Okay. So if I write the force formula, F A is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by say d square. This is for what? Air. Now, what is it? Another one? Now the same two charges, say Q1 and say Q2, are separated in, or else it's kept in some medium. What medium? We don't know. Some medium. Okay. Say it's placed at a separation distance of dm. Okay. Now what is the force? Now the force in the medium is equal to 1 by 4 pi epsilon naught Q1 Q2, let us K into dm square. I simply took the K from here to here. So for easier comparison. So what is given? Given question is the force between the 2 point charges separated by the distance d in air medium and in a given medium are same. Force is same. So what is given? F A is equal to F M. Then what should be the distance dm? So we'll compare this. So 1 by 4 pi epsilon, 1 by 4 pi epsilon common. Q1 constant, sorry, Q1 Q2 same, Q1 Q2 here same. So what is now? I can write like this: 1 by d square is equal to 1 by k into dm square. Am I right? All right. Now, what the question asked that implies what is dm? Now, dm square is equal to d square divided by k, or that is equal to dm is equal to d divided by root k. So the option is d divided by root k. The option is C. Next question. 54th. In the adjoining figure, the capacity of each capacitor is 8 microfarad. The equivalent capacity between point A and B will be. So we are asked to find what is the effective or the equivalent capacitance between A and B. So what is the easiest one? It's not clear whether they are in series or parallel. So let us use the technique of naming the plates. So let us name 1, 2. This is 3. This is 4. Say 5. 6. This to be 7. And let us say this 8. Okay. Now see. Now let us see what is where and all A is connected. Okay. Now A is connected to which plate now? It is connected to a plate number 1. See. It is connected to the plate number 1. So obviously the other plate must be 2. So let it be. Now A is again goes here and goes to the plate number 4. So A again it is connected to another plate which is nothing but the plate number 4. So let us think A is connected to that. Okay. And also A is connected to 5, plate number 5. So let us take one more capacitor here. So plate number 5, the opposite another plate of the capacitor is 6. So A is connected to plate number 5. Okay. Now the same wire goes and here it connects to again 8, plate number 8. So again it connects to a plate number 8. So plate number 8 is connected to A. So if this is the plate number 8, this is 7. Now let us see. Now what about the B1? Now coming to the B. So B is where and all B is connected. B is connected to the plate number 7 and 6. So plate number 7 is connected. And say if this is a 4 and this must be the 3 1. So B is connected to 7 and say 6. 7 and 6. Again it is connected to 3 and 2. So B is again connected to 3 and it is connected to 2. So see how it looks now. It looks now as if all the capacitors are in parallel. So now it's a very simple one. When the 4 capacitors, identical capacitors are in parallel, Cp will be equal to 4 times that of the C. That will be 4 into 8. So that is nothing but the 32 microfarad. So the option is C. Right. 55th. An ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27th of its original volume. So what is T1? T1 is 27 degrees Celsius. That is nothing but 300 Kelvin. And V2 is equal to 8 by 27 times that of the V1. And gamma is given to be 5 by 3. Okay, now what's the question? Then the rise in temperature is, since it is adiabatically compressed, so during the compression temperature raises. So what is the temperature is the one what we are asked to find, and the volume is the one which is given parameter. So better we can go with the relation TV relation. So TV raised to gamma minus 1. It is a constant. So I can write T1 V1 gamma raised to 1 is equal to T2 V2 gamma raised to 1. Say this, I can write it as, say, V1 by V2 whole raised to gamma minus 1 is equal to T2 by T1. Or that implies T2 is equal to T1 into V1 by V2 whole raised to gamma minus 1. Right? All right. So now what is T2 then? So T2 is equal to T1 is 300 into what is V1? So V1 is, V2 is nothing but 8 by 27. So we'll write this 27 by 8. 27 by 8. What is gamma? Gamma is nothing but 5 by 3. So it is 5 by 3 minus 1. So that is equal to 300 into 27 by 8. This is for 3. So this I can write it as a 2 by 3. So what we have to take? We have to take the cube root of this first, and then it becomes a square. So this is nothing but 300 into cube root of 27 becomes equal to 3. 3 square it becomes equal to 9. 8 cube root becomes 2. 2 square becomes a 9. So this will be equal to, so what we are going to get is nothing but 675 Kelvin. On simplification, you will get 675. Now what we are asked to find, what is the rise in temperature? So what is the rise in temperature? Delta T is equal to T2 minus T1. So that is nothing but 675 minus 300. That is equal to 375 Kelvin. So 375 Kelvin, that is T. Right. Okay. For an ion having a single electron, that means we can apply any equation which is used in the hydrogen atom. The following wavelengths are observed. So that is what, when an electron which is present in the E3 energy level, when it jumps to the E1 directly, it releases, say, lambda as a 40 millimeter. And when it is jumps from E2 to E1 directly, it goes 60 millimeter. Then what you are asked to find, the wavelength of lambda is. So in the picture, what we are asked to find the lambda. So what we can write, the energy gap between the E3 and E1, I can write it as sum of the energy gaps between E2 to E1 and E3 to E1. So I can write it as, say, the energy gap between, say, E3 minus E1, that is the energy gap, that is equal to the E3 minus E2 plus, say, E2 minus E1. So what is this energy? So E3 minus E1. So E3 minus E1 is nothing but the energy of the photon emitted when it electron jumps from here to here. So I can write this as hc by lambda of the wavelength which jumps from 3 to 1. That is equal to hc by 3 to 2. So I can write lambda from 3 to 2 plus hc by 2 to 1. So I can write lambda 2 to 1. So this, there is hc. What the cancels out 1 by what is lambda 31? Lambda 31 is nothing but 40 millimeter given. That is equal to 1 by what is lambda 32? That is what we are asked to find, plus 1 by 60. Or else that implies 1 by lambda is equal to 1 by 40 minus 1 by 60. So that is equal to 1 by say 20. I will take it outside. 2 minus 3. So take the LCM. So this becomes 1 by 6. So it becomes a 1 by say 120. So that becomes equal to lambda is equal to 120 millimeter. So this, right, 57th. A, B, C are the 3 points in a uniform electric field. The electric potential is. So this is the uniform electric field. So same, this is the electric field. So what we have the relation? We have E is equal to minus dV by dx relation. L or X. What it says, ಇದು ಏನು ಹೇಳುತ್ತೆ ನಮಗೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ಕೊಡುತ್ತೆ. What is the direction of electric field? The direction of electric field is in such a direction where there is a negative potential gradient. Negative potential gradient means as the potential gradually decreases, or else I can say the direction of electric field is such that the potential gradually decreases along the electric field. ಯಾವ ತರದಲ್ಲೂ ನಾವು ಅದನ್ನು ಇಂಟರ್ಪ್ರಿಟ್ ಮಾಡಬಹುದು. ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲೇ ಮುಂದೆ ಮುಂದೆ ಹೋಗ್ತಾ ಇದ್ದಾಗೇನೆ ಪೊಟೆನ್ಷಿಯಲ್ ಗ್ರಾಜುವಲಿ ಡಿಕ್ರೀಸಸ್. ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾನು ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನು VA ತಗೊಂಡ್ರೆ, say here if I take the potential to be VB and the potential to be VC, obviously what happens? As we move along the electric field, its potential has to decrease. So I can say VA is greater than say VC and VC should be greater than VB. So potential gradually decreases along the electric field direction. So which is the option correct? So here you can say it is a maximum at C. No, it's not possible. Same at all the 3 points A, B and C. No. Maximum at A, yes, this is possible. Maximum at B, no. So option has to be the A. So ಇದು ಯಾವಾಗ ಆಗುತ್ತೆ? ಸೇಮ್ ಎಟ್ ಆಲ್ 3 ಪಾಯಿಂಟ್ಸ್. ಸೇಮ್ ಈಗ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾನೊಂದು ಪ್ಲೇನ್ ಅನ್ನು ಇಮ್ಯಾಜಿನ್ ಮಾಡಿದ್ರೆ, so any plane, that is what we call as nothing but the equipotential surface. So a plane perpendicular to the electric field, ಈ plane ನ ಮೇಲೆ at every point potential will remain constant. So here what is the question as? A point, B point and C point. That is why the maximum at A, minimum at B. Okay, the next part question. In the above circuit, the magnitude and the direction of flow of current through the point E is. So you are given with the circuit. So to find the direction of the current, the two methods you can use. One, you can use the Kirchhoff law you can use. Otherwise, you can find out the effective EMF of these two and then apply the formula. Let us now take it nothing but the say Kirchhoff loop law will apply. Say we'll assume a current like this and we'll apply the Kirchhoff's loop rule. So potential drop across these resistors and we'll find the EMF sum. So altogether it has to go to 0. That is what the meaning of the Kirchhoff's loop rule. So let us take the direction is in this direction. So we'll take it as a minus 2I, that is potential drop across 2 ohm. Another potential drop across a 2 ohm, then I can write it as a 2I. 1 ohm is there, so potential drop I can take it as 1 into I. Then this 6 volt, it sends a current in opposite, so it will be 6, and this EMF will be 2. So altogether the algebraic sum has to come to 0. So that implies, say, minus 5I minus 4 is equal to 0, or I is equal to minus 0.8 ampere. Okay, then what is the meaning of minus? So minus should be the direction what we have assigned is from D to A, but we are ending up with the minus 1. That means the current has to flow in opposite direction. So current has to flow from A to D through E with a magnitude of equal to 0.8 ampere. So 0.8 ampere from A to D through E. So option has to be this one. So it has to, current has to flow from A to D, not from D to A. ಇನ್ನೊಂದು ಮೆಥಡ್ ಅಲ್ಲಿ ಮಾಡೋದಿದ್ರೆ ಇದರ ಎರಡರ EMF ಎಷ್ಟು ಬರ್ತದೆ? So this EMF, say, minus plus plus minus, so total EMF, so effective EMF becomes equal to this 6 minus 2, so that is comes 4 volt, because the terminals are, it is not plus and minus joined together, it becomes plus and plus, so it becomes 4 volt. Then the current I will be equal to E divided by how many resistance are there? 1, 2, and 3. So 2 plus 2 plus 1, so it becomes 5. So it becomes 4 by 5, that is equal to 0.8 ampere. So we can go with any method. So now this answer will be here. It is a 0.8 ampere from A to D through E. Right. 59th. Which logic gate is represented by the following combination of the logic gates? So this is a NOT gate, this is a NOT gate. So if this is the A, then this will be the A bar. If this is B, this will be the B bar. And these outputs are given as an input for this NAND gate. So this I will write as the A bar, and this is the B bar. This is a NAND gate. So NAND gate formula is nothing but the input A bar, and this is the B bar input, so whole bar. So this you can write it as A bar. So that this equal to, this can be equal to A bar and changes to or, this becomes B bar bar. So De Morgan's law, you have to apply this. So this becomes equal to A or B. So simple. So it becomes an OR gate. All right. Now, the last question of this paper. A system of two charges separated by a certain distance apart stores electrostatic potential energy. So what type of system of two charges you can think of? Either you can think of a like charges. So like charges, then either this may be plus plus or minus and minus, or else you can think of one as plus and one as minus. If the distance between them is increased, so what is happening? If the distance of separation between them is increased, what happens to the potential energy of the system? Okay. So potential energy formula, what we have the potential energy formula? U is equal to 1 by 4 pi epsilon naught into Q1, say Q2 divided by R. Right? So this is not the formula we have. Potential energy formula. Now the condition is if they are, say, like charges. If they're like charges, what happens? The product of this Q1 and Q2, product of this Q1 and Q2 will be always greater than 0. If they are the unlike charges, that is one is plus and one is minus, then the product Q1, Q2 always comes to be less than 0. That comes to negative. Okay. Now, so in this case, say if the Q1 and Q2 is greater than 0, and then the U will be, so this comes when the U comes to be always positive. Correct now? Whereas here the U comes to be negative. Okay. Now you see, if in this case, if I go on increasing the distance, that is, if the distance is increased, what happens to the potential energy? Potential has to decrease. So here in this case, what happens to the potential energy? Potential energy decreases if R is increased. Now, in this case, what happens? If U is negative, U will increase as the R is increased. Why? Because say for one certain distance, if the potential energy says minus 10 joule, if its distance is increased, numerically its value decreases. Say it becomes say minus 8 joule or minus 7 joule. But what happens? Negativity is gradually decreasing, so the potential energy is increasing. So whether it is increase or decrease, it depends on what type of charge assembly it is there. So whether we have a like charges or whether we have the unlike charges. So you cannot decide here whether it is decrease in any case. No, it's not possible. Increase in any case, this is also not possible. So which is a possible answer? Possible answer is may increase or may decrease depending on what type of charge assembly it is, whether it's a like charge assembly or the unlike charge. So the option has to be the C one. Okay, so we have solved this 60 question in some duration of almost say 2 hours, more than 2 hours. So here, since we had a lot of discussion and the writing part, it took the more time. So ನೀವು ಯಾವಾಗ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ತಾ ಕೆಲವು ಫಾರ್ಮುಲಾಗಳನ್ನು ಬರೆಯದೆ ಡೈರೆಕ್ಟ್ ಫಾರ್ಮುಲಾವನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಡೈರೆಕ್ಟ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಅನ್ನು ಈಸಿ ಮಾಡ್ಕೊಂಡು ಹೋದ್ರೆ ನಿಮಗೆ ಆದಷ್ಟು ಬೇಗ ಇದನ್ನು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗತ್ತೆ. ಸೊ ಈ ಕ್ಲಾಸ್ ಅನ್ನು ಮುಗಿಸುವ ಮೊದಲು say here there is a step. So step is everyone's intention is to go to this the topmost step wherein we have the top rank. And what takes you to the top rank is nothing but the confidence what we have. When we get a confidence, when we work hard, not only the work hard, we should work in a smart way. So hard work plus smart work together, it gives you enough confidence to reach the top. So I wish you all the best for the upcoming the CET exam. ಎಲ್ಲರೂ ನಮ್ಮ CET ಪರೀಕ್ಷೆಯನ್ನು ಉತ್ತಮವಾಗಿ ಬರೆಯಿರಿ. ಎಲ್ಲರಿಗೂ ಒಳ್ಳೆ ರ್ಯಾಂಕ್ ಸಿಗಲಿ. ನೀವು ಓದಿದ್ದಕ್ಕೆ ಕಷ್ಟಪಟ್ಟಿದ್ದಕ್ಕೆ ಎಷ್ಟು ಪ್ರತಿಫಲ, ಒಳ್ಳೆ ಪ್ರತಿಫಲ ನಿಮಗೆ ಸಿಗಲಿ ಅಂತ ಹೇಳ್ತಾ ಮುಂದಿನ ನಿಮ್ಮ ವಿದ್ಯಾಭ್ಯಾಸಕ್ಕೆ ಶುಭವನ್ನು ಹಾರೈಸ್ತಾ ಇವತ್ತಿನ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಇಲ್ಲಿಗೆ ಮುಗಿಸ್ತಾ ಇದ್ದೇನೆ. ವಂದನೆಗಳು.